Continuation of properties of exponents. Power to a power property. When you have a base raised to a power, raised to another power, to simplify, you multiply the two powers together. In this example, we have w to the 6th power raised to the 4th power. To simplify, it will equal w to the 24th power. Now in this case, again, we know that anything raised to the 0 power equals 1, and anything 1 raised to any power is simply 1. Pause and try. So this one is 5 to the 15th power. Pause and try. This one is x to the 18th power. Our next property is the power of a product property. And that is when we have a quantity raised to a power. To simplify, you take that power and you give it to everything inside the parentheses. So in this example, we have the quantity xy raised to the 2nd power. To simplify, I take that power and I give it to everything inside the parentheses. So I end up with x squared y squared. So be careful, because when there's a number inside a quantity raised to a power, make sure you don't miss the number. That number needs to get that power also. So in this case, we end up having 2 to the 3rd power, x to the 3rd power. And because we can simplify 2 to the 3rd power, we need to do that. So 2 to the 3rd power equals 8, x to the 3rd power. So this quantity, 2x to the 3rd power, will simplify to 8 to the x to the 3rd power. Pause and try. 8x to the 3rd power. Pause and try. So we end up with 25x squared y squared. So now most of the time when we do properties of exponents, it will be a combination of properties that we will be working with. So in this case, we're going to be doing a combination of a power to a power and a power to a quantity. So when we have a quantity raised to a power and then what's inside has powers, you need to take that power on the outside and give it to everything inside by multiplying the two powers together. So this x squared y to the 6 raised to the 2nd power, when I simplify, I end up getting x to the 4th power, y to the 12th power. That power on the outside gets multiplied to the powers inside. When we have a combination property, be careful not to miss the number. That power that's on the outside needs to go to everything inside, including the number. So when we do this, we end up having 3 to the 2nd power, x to the 10th power, y squared, z to the 6th power. And then you want to make sure you simplify or do the multiplication of 3 to the 2nd power, which equals 9. Pause and try. So here we get 27 x to the 15th, y to the 12th. So now we have a combination of a quantity to a power with powers inside, and then we also have multiplication property. So we have to do this in the right order. So the first thing we're going to need to do is we're going to need to do the power to a quantity and then using that power to a power rule. So I'm going to just work with the first piece. I'm going to take that power and give it to everything inside. I have a negative 2 to the 3rd power, a to the 3rd, and b to the 6th. 2 times 3 is 6. Then I'm going to work with the second piece, and it's multiplication. So I end up having 8 squared to the 4th power, so I end up getting a to the 8th. Now I have to simplify. To simplify here, I'm going to do pause and try. So the first step is to take that power and give it to everything inside. We end up with d to the 20th, e to the 9th, and then don't miss that number. 3 squared is 9. Then we get d to the 10th, e squared, and now I need to multiply, which is the addition of the powers, so of like bases. So I end up with 9 d to the 11th, e to the 11th. I'm sorry, d to the 31st and e to the 11th. Now we're going to work with the quotient raised to a power. This is similar to the power raised to a product. You take the power on the outside and you give it to everything inside. So when you have a quotient raised to a power, to simplify, you take the power and you give it to the x and the y, and you end up having x to the 5th over y to the 5th. So this is also the combination of a quantity raised to a power and the power to a power. So you're taking that power on the outside and giving it to everything inside, and when they have powers inside, you need to multiply the powers together. So in this example, we end up getting r to the 16th over s to the 10th. Pause and try. So be careful here not to miss the number. Again, we have 3 to the 3rd power. That's where the 27's coming from. And then we end up with a to the 15th over 27b to the 6th. So now when you have a combination of properties and you have a quantity inside or quotient inside and it raised to a power, I find that it's simpler to simplify inside first, and then take that power on the outside and give it to everything. So when I simplify inside, I like to break it into pieces. So the first piece, I look at the fraction part. If the fraction can reduce, I'm going to reduce it. And in this case, 2 over 3 is reduced, so I don't need to simplify. I'm looking at the next piece here, which is the a to the 3rd over a to the 5th. And again, wherever the higher exponent is, you're going to subtract and leave it. So in this case, we end up with a to the 2nd in the bottom part. And the last piece here, we have b to the 7th over b squared. So I'm going to subtract, and it's going to stay on the top. Now that it's simplified, it's easier to take that power on the outside and give it to everything inside. So we end up having 2 to the 3rd, b to the 15th over 3 to the 3rd, b to the 6th. Again, I'm trying to emphasize, don't forget to give that power to the numbers also. And then you'll need to simplify or evaluate the exponents. So we end up getting 8 b to the 15th over 27 a to the 6th. Pause and try. So this is an example where it's very useful to simplify inside first, because you see this 5 over 15 will reduce, and we end up getting 1/3. And then that a to the 7th over a to the 5th, the higher exponent's on top, so we simplify and it stays on top. We end up with a squared. And then the b over b to the 4th, we subtract and stays on the bottom, we get b to the 3rd. Now that it's simplified, I'm taking that power and I'm giving it to everything inside. Remember, we do not need that 1 because there's something left on top, so we end up with a to the 4th all over 9b to the 6th. So now this is a combination property, but it's different from the previous because the power on the outside is not the same. So I can't simplify first. In this case, I have to take the power on the outside and give it to everything inside before I can actually simplify, because they're not all in the same parentheses. So in this case, I have to do the powers first. I'm going to take that power on the top, I'm going to give it to everything inside, and end up with x to the 3rd, w to the 15th. That power on the bottom, I'm going to give it to everything inside, and I end up with x to the 4th and w squared, and now I can simplify. So you're reducing or simplifying using the division property. So the first one, the higher exponent's on the bottom, so I'm going to subtract and it's going to stay on the bottom. I end up with x. And the second piece, the higher exponent's on top, I'm going to simplify or subtract, and I end up with w to the 13th. So this type of problem, you have to do the powers first and then simplify. Pause and try. So you have to be careful here because you're taking that power on the outside, giving it to everything inside. You end up with 8 x to the 15th, y to the 3rd, all over 16 x to the 4th, y squared. And then you're going to simplify, and we're looking at the 8 over 16. That's going to reduce to 1/2. And then we have x to the 15th over x to the 4th. We're going to subtract, and it's going to stay up top. And then we have y to the 3rd over y squared. We're going to subtract, and it's going to stay up top. So our final answer, we get rid of the 1 because we don't need it because something's left up top. We get x to the 11th y all over 2.